Welcome. Today's demo is going to be a Yanmar cogeneration unit, a micro cogeneration unit. This is a 5 kW model. We're going to talk a little bit about what cogeneration is and what it isn't. So let me start with the setup we've got here. We've got an inverter for the battery banks. We've turned that on to get power to this demo trailer. We've got an inverter for the cogen unit to transfer power when to the customer's grid. And if we come over here, we've got our 5 kW Yanmar system, and we're going to put it in test mode to fire it up. First, we've got to put the power on. Got to wait for that to boot up first. And we're going to go, as soon as we get the run hours on the main screen, almost there. Okay, 61 run hours. Going through a pre-purge setup. Sorry guys, I don't have a key. Okay, so we fired up the unit. We can see how quiet the unit is. Over on this side, we've got our hot water outlet and our cold water inlet. We're going to use the heat off the engine that's producing electricity. We're using the waste heat to heat hot water. So we're going to let this water start to run. We're going to see what the cold water temperature is right now. Okay, so we're getting about 70 degrees of the ambient water. And we're going to come back in a few minutes after we've had a little bit of run time to see what kind of temperature we're getting up to.
So is it like a generator? Power goes out?
That's a great question. So essentially it's like a mini power plant in your home. This is installed outside the home, or could be inside, or a light commercial building, small commercial building. And you run gas to it, you run electric to it for it to start up. And then it runs typically while your house is still being operated by electricity from the grid, but it's using its own energy to offset the power you're buying from the grid. So it fires up, it provides power to the house, all right, not all the power, but some, if not most of the power, and then as the natural gas engine inside heats up, just like your car, you would normally have a radiator on your car with a fan to get rid of that heat from your engine. Well, instead of blowing the heat out of this to the outdoors, we're capturing the heat right here with a heat exchanger, and then we can use that heated water for things such as your domestic hot water. So
I can save money on my gas bills by getting my hot water through here.
That is correct. So we'll see what kind of temperature we're up to now. Look at that, remember we started at 65? The water in this tank right now. So we're now up to maybe 105, and that'll continue to climb. So we're using we're using this waste heat to heat water, and that water is either for your domestic use, clothing, clothes washing, bathing, domestic, or you pipe it into your heating system with a hot water coil and you can blow hot air around the space. So let's come on over here. We'll look at this inverter is the unit that is taking the power output from here and feeding it into the home or a commercial space. So right now, let's look down here. It goes through this menu. We're going to wait for it. Gives you information what type of grid we're on, how many pounds of CO2 we're saving, and we're using 1261 watts currently. All right, and that's just the lights up here, the pump for the sink. That's what's being used. Now I've got an air conditioner here, so let's put a load on this system. So let's say the house or the building needs its air conditioning to come on. All right, so we're now going to see what this is sensing in terms of needs for the house, and this is going to ramp up power production wise. Let's see what we're up to now. Again, it's going through its menu. CO2 saved. 2,667 watts with the air conditioner on. So you see the power ramping up when the needs are there. So we'll turn the air conditioning back off. And you see how quiet it is.
You can barely hear it.
When you're mounting them inside, you've got to vent it, obviously, to the outdoors, or they're rated to be mounted outside as well. So one interesting fact, you know the little 60-watt light bulb you've got in your house? Mm-hmm. So that 60-watt light bulb, just to give you an idea of what line loss and utility company inefficiencies are, that 60-watt bulb needs the power plant to be producing 240 watts. So the power plant produces 240. It's about, I don't know, 50% efficient. Then it comes through the underground and overhead wiring. It loses its capacity underground or overhead. By the time it gets into your house, to burn that 60 watts, you'd had to produce 240. So this concept is taking the power plant from hundreds of miles away and putting it right outside your home or business. So you have very little line loss. You're producing power here, and on the other side of the wall is where you're using it. So this thing is about up to 85% efficient. So again, just to recap, you are producing electrical power for your home, but you're really doing it only when you need heat. So the call in most situations, I need hot water or I need heat. This comes on, and to provide that heat, it runs its generator to produce electric. It's a little backwards in its thinking, right? But that's the concept. The utilities are giving big rebates. I understand that there might be a $2,000 per kW rebate, and this is a 5 kW unit, so that's a $10,000 rebate from the utility company. Let's see where we are temperature-wise. Wow, what are we reading? We're up to 140 degrees and still climbing. Yeah, so I believe this unit has a max production of 150 degrees.
Wow.
Now, if you've got a baseboard hot water system, typically we would install this hot water out and cold water in. We install that in a loop upstream of the boiler. So this would be providing preheated water to the boiler, and then from the boiler it would go out into the building. And such times when either this thing's down for maintenance or the load is so great that you need more than 150 degrees hot water, the boiler would kick on and supplement. But to bring it from 150 out of here up to maybe 180 in some baseboard situations, you don't have to move it that much, so the boiler doesn't have to run that long.
Yeah, 180 is max.
Yeah. So again, outside you'd have a little stub of an exhaust pipe. Inside you vent it all the way up here. Can't think of it. This thing has a 10,000 hour runtime. So in most residential light commercial applications, that would equal probably every year and a half or 2 years maintenance schedule, and you'd have to do a full maintenance on it with filters, oil change, plugs, the whole 9 yards. And then we show up and do the maintenance. We'll plug a laptop into that. If there are any updates from the factory, we'll update their programming control boards, and any EEPROM upgrades, we'll do that at the maintenance intervals. And that is the Yanmar Micro Combined Heat and Power Unit.